variance and standard deviations. In 2.4 we will discuss another measure that can be used to work out the spread of data. What are we doing now? We are doing uh, creating tools to measure a data set, to assess a data set. So we under measure of location we have mean in hand, median, and mode, and first quartile, and third quartile. Median is the second quartile, and measure of spread we have. Then the percentiles, and then we have in the measure of locations IQR, interquartile range, then uh, interpercentile range. So those are some tools. Then out of that we know that mean is a strong one because all the data contribute to make the mean. Because when we find mean, we are adding up all the data and divide by the frequency. So it means all the data contribute to uh, for the preparation of mean. So then when you look at all the measure of spread, measure of locations, I think mean is one good trustworthy one because as I said, it is contribute all the data contribute to make the mean. Then I'll keep that mean as a key location or one of most recognized values in the data set. Then when I keep this person is the most reliable one, then I will assess other data. How far from that the reliable person. Now assume that I have a data set 1, 2, 3, 4, 5. So I have a data set in my hand now. So then the most reliable person I select mean. So mean is x bar. So 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So this is going to be 5 plus 4, 9, 12, 14, 15 divided by 5, 3. Now we found out x bar is 3 now. So he is the key person in this group. Now mean is 3, and the meaning of that we are going to represent all these 5 numbers as 3. This is also 3, 2 also as 3, and this one also as 3, and this is also 3, and this is also 3. So then what is the difference? How accurate this? So we want to assess how far the other individuals away from this mean. So for example, 1 minus 3, it is 2 away from mean. When this is 2 minus 3, that is 1 away from mean. This is 4 minus 3, that is positive 1 away from mean. And 5 is 5 minus 3, positive 2 away from mean. Now what is the variance? So what is the total difference? Not variance, what is the total difference? So total difference is 0. Can it be because plus 2 minus 2 cancel out? This total difference is 0? No, this is a wrong way working out. Because this minus and pluses, this difference is cancelling out. Now I need to come out of a method. I need to find a different method. We need to find a different method to assess these deviations still uh, without cancelling this each other, minus 2 to plus 2. The best approach is for that is take the difference 1 minus 3 and square it. We'll take the square form, then we are avoiding the negatives. So 1 minus 3 is minus 2 square, minus 2 square is 4. Then 2 minus 3 is minus 1 square is 1. Then 4 minus 3 and 1 square is 1, and 5 minus 3, that is 2 square is 4. Now I can find the total square difference. So this is going to be 4 plus 5, 8, and this is 10. If I summarize again, now we need to find this 3% how far, because 3% is the person who is going to represent all the other persons. Then how far this 3% away from them, and when we try to find out, uh, we are having an issue that minus is appearing, and when we add, this is cancelling out with the pluses, and we can't get the total difference. So this is 2 minus 2 different, and as a result, because of that, we square this one and we are turning into a positive form, and we are looking in the square form now. So I will rewrite this one like this. uh, 1 minus 3 square plus 2 minus 3 square plus 4 minus 3 3 minus 3 square plus 4 minus 3 square plus 5 minus 3 square square root. So then we will get the total. Actually, we don't need to write this one. 3 minus 3 is, we know it's 0. We can void. To complete the note, I will write 3 minus 3 a square. They all squares. So this is 0 square is 0. Still 10. So we can write like that. So this is for 10. This is for how many values? This is for how many values? This differences. This differences squares uh, is for 5 values. So if I want to find one value, so I will divide by 5 this one. So in terms of here, I am dividing. So we found out this value is 10. So this is 2 square, 1 square, 0 square, 1 square, and 2 square over 5. This is 10 divided by 5, 2. So now this is in the square form. So when I take the square root value, so this is the average deviation from one number, from 3, or from mean. So this 2 is the variance. This is in the square form, and when you square root this value, you will get the standard deviation. So you found out the variance, and then when we take that, this is in the square form, and when you take the square root, we can so that is the average distance from 3. So So this part usually we refer as uh, sum, right? Sum of what? Squares. Sum of squares. Only top part. Now, if I take this is x bar, this is x1, x2, and this is x3, x bar become x3, and this is x4, and this is xy. Okay, I will take this one x1, x2, x3, x4, x5, and x bar is 3 now. We found out. Now what is happening here? x1 minus x bar square plus x2 minus x bar square plus x3 minus x bar square plus x4 minus x bar square plus x5 minus x bar square divide by 5. It means we can write this one. This is variance. Uh, variance we refer as V. So how do you find the variance? Find the mean value and find the distance from that mean value to other numbers and square it. And that is for whole 5 values. So we need one value. Because of that we need to divide by 5. So I can write this one. I equal 1 to 5 xi minus x bar divide by n. So sorry, divide by 5. And when I started this one, I equal 1 to n xi minus x bar divided by n for any number n. So this is the variance. And square standard deviation is square root of variance. So standard deviation is square root of summation I equal 1 to n xi minus x bar over n. So now we decide in this game the mean is a good person because it represents all good numbers, and we found out how far this other numbers from the mean. So the technique was we square and average that square, and that is the average value is variance, and when you square root it is the standard deviation. Now my question is, I have two samples, x bar is 3 and x bar is 3, right? Okay, I'll put x1 bar and x2 bar, two samples, and I will tell that this is 25, v is 25, and this variance is 36. So which sample is better now? So v is 25, and okay, standard deviation is, we can find a standard deviation, square root v, which is the square root 25, it is 5. So and when v equal 36, z is the square root 36, that is 6. Okay, this is, if this is sigma is 5 and this is sigma is 6. However, v is following sigma. If v is high, sigma also high. Now assume that this is A farm, this is B farm, you are the apple buyer. Then I'll ask what is your standard deviation. Let's say okay, I will put 70 and 70 big value 70, and what is your standard deviation? So A is telling that or the variance is 25, and B is telling my variance is 36. Then which one is more reliable? The reliable is this one because variance is little. This is high variance, very high. So this is the idea behind it, the variance. Just to summarize again, um, so same mean, but this variance is low, this variance is high. Hence the A form is good because the same mean but less variance. Let's discuss one example. I have a number set here: 1, 2, 2, 3, comma 3, comma 3, comma 8. So 1 frequency 1, 1, 2, 3, and 3 is 3, and 8, 1. So what is x bar now? 1 times 1 plus 2 times 3 and 3 times 3 and 8 times 1 over 8. Frequency is 8, so that is going to be 24 divided by 8 is 3. So those are x values. Those are x values. And relevant f. So 1 times, and we found out the x bar mean. Now we want to find how far from the other. So this is going to be 1 minus 3 square. This is going to be 2 minus 3 square, and this is going to be 2 minus 3 square plus 2 minus 3 square plus 3 minus 3 square plus that all 3 is going to be 0, 3 square plus 3 minus 3 square plus 8 minus 3 square, and divide by what? Divide by 8. This is variance. So actually we can write like this smartly: 1 minus 3 square. How many? So 1, how many 2's there? Take 1 2. So 2 minus 3 square. So this is the difference. So how many this kind of difference? 3. 3 times. And 3 minus 3 square. How many this kind of difference? 3. And then 8 minus 3 square. How many this one? 1. So instead of writing like this, we can divide by 8. Actually, now we know x bar is what? X bar is 3. Now we have the frequency. So 1 is 1 minus 3 square. How many frequencies? 1. Then take 2. 2 minus 3 square. How many frequencies? 3. And then 3 minus 3 frequencies. How many of this one? Sorry, how many of this one? 3. And then 8 minus 1 squares. How many of this one? 1. Divide by 8 total frequency. So this is going to be 1 minus 3 mean 2 square 4. This is 2 minus 3 is 1. Then 1 square is 1 times 3 is 3. This is 0. And this is 8 minus 3, 5. 5 square 25 over 8. So this is going to be 29 plus 32 over 8. So V is 4. Then standard deviation sigma is square root V, which is square root 4 is 2. What will happen if we have a class interval? Assume that 0 to 10 frequency 0 to 10 there are 5. So this is x and this is f. Then 10 to 20 there are 4, and 20 to 30 there are 6. Now how do you find the standard variance? So I found out here x bar is 15 approximately. Now how do we find where's the x value? We don't have x value. So then what we have to get the mid value? So 0 and 10, 0 plus 10 divided by 2, 5. 10 plus 20 divided by 2, 15. And 20 plus 30 divided by 2, this is 25. Then we can find the variance is, instead of this one, well, we don't consider this one. Now we have 5, 15, 25, 5, 4, 6. Then how do we do? This is the value. 5 is away from 15 x bar square. How many? 5 plus, then the second one 50. We don't need to write 15 minus 15. The other one is, okay, I'll write 0. Okay, for the understanding I write 15 minus 15 square times 4, and then 25 minus 15 x bar square. How many? 6. And divide by this value by 15. So when you have instead of this one numbers, if there is a class interval, what do you need to do? You have to get the mid value and you have to minus from the mean. Not minus from the mean, that value has to minus has to be take out subtract from that value. Mean has to be subtract from those values. So in general we write variance is summation x minus x bar square over n. This top part we call is x over n, or sum of squares over n. So what is SXX? XXX is summation x minus x bar square. Now actually I'm going to simplify this variance part for the student who is doing higher mathematics. So summation, this is going to be x minus 2x x bar plus x bar square. This is x square. I square this one, divide by n. Then this is going to be summation x square minus 2 summation x. I expanding with the summation. I put inside here because 2 is a constant, and x bar, there is no influence of sigma for x bar, is a constant, and then sigma x bar square over n. So I can write this one as sigma square over n minus 2 sigma x bar over n, plus this is sigma x bar. So this is going to be nx bar square, this is the place you may not sometime understand, just leave it, because over n, let's see, 1 equal 1 to 5, I equal 1 to 5, so, so let's say a, what is the meaning of this one? 5 times a, you want to add a plus a plus 1 2 3 4 5, which is 5a. Now we are working with 1 I equal 1 to n x bar. Then you have to add x bar how many times? N times. That's why n x bar. Here n x bar. So this is going to be summation x square over n. This is 2 summation x over n times x bar, also summation over n. And this n to this n cancel out. This is x bar. X bar means summation x over n square. So now this is summation x square over n minus 2 summation x over n square plus summation x over n square. This is like minus 2b plus b. If this is b, then answer is minus b. So likewise, this is going to be summation x square over n minus summation x n over square. In other way, summation x square over n mean summation x n divided by n mean x bar square. So finally we can write summation x square over n minus summation x over n square. You can see this one in the book. Now assume we discuss about the data that's 2 2 2 and then x bar equal 3. Then we write 2 minus 3 square plus 2 minus 3 square plus 2 minus 3 square. Instead of that, we said this is easy to write 3 times 2 minus 3 square. It means f times x minus x bar square. It means if there are repetitions like that, we can bring to f symbol here. Then n become summation f. N become summation f. Then this n becomes summation f. And when you have f, then you will get f everywhere. Okay. We'll keep actually f outside, and we are working keeping f outside. F outside. Now this is n is what? Summation f. So I have to change everything to summation f, summation f, summation f, summation f, summation f, and finally I'm keeping this f outside, and now I'm substituting f inside f, and this is summation f, and then this is going to be summation fx and summation f. So this is fx square summation f, and this is basically still the x bar. So basically with this one again, variance is uh, summation instead of fx square, and n becomes summation fx and minus then summation not x fx over summation f. This is going to be square. Now we have two formulas. One is this one, and the other one is this one. Actually, we are going to use this one most often, and we'll work two examples and then do the exercise. Now let's discuss example number 8. Shama's record in the time, example 8 in the book, spent out of a school during the lunch hour to nearest minute X. Female student in year this is right. Okay. So this is the table. So how many days she did this research? You can get when you get the summation F number of days. Now I like to know, I work differently. First of all, I will find X bar first. So X bar is 35 days 3 times, 36 17 times, 37 29 times, and 38 34 times, and divide by total number of days equal 83. So this X bar is going to be roughly uh, 37.13. Now variance. Uh, this is the value 35 minus 37.13, that is the difference, and this square how many values 3, and 36 minus x bar 37.1, how many values square 17, and then the other value 37 minus 37.1 square, the other value is 29, and then 38 minus 34, 38 minus 37 point x bar square, how many values? 34 values, and divide by n, which is 83. See, for a one value, 35 minus 37.13 the difference. To make the error, square it. To make positive. Difference, 36 minus 37 and square it. Take that difference from here, square it. And likewise now, this difference is 3 times. This difference is 17 times. 37 minus 37 by that difference is 29 times. And divide by, this is for 83. So to find 183. It approximates 0.741, and that is V. So if you want sigma, square root V. So square root V value 0.741, 0.86. Uh, we can use the formula V or sigma square. Formula is summation fx square over summation f minus summation fx over summation f square. How do you remember this formula? You can write summation fx over summation f, summation fx over summation f. The same term two times, and this is square like this, and this is square like this. When you look at this one, now you can see that you need three things. Summation f1. Other one is summation fx square. And other one is summation fx. So summation f mean these things. 3 plus 17 plus 29 plus 34, that is 83. Now summation fx square. right? So this is f x square, 3 times x square, 35 square, add 17 times 36 square, 29 times 37 square, and 34 times f times 38 square. Then summation fx, 3 times 35 and 17 times 36, 29, 37, 34 times 38. When you drop this square part, that is this one. Then substitute these values. Uh, this is 114, 114, 504, summation fx 3882, and let's substitute now. Sigma square or variance is this one. Summation fx square mean 114,504 divided by 83 minus, then bracket, this is 3082 83, this is mean basically, square, and you will get the answer as 0.741 47. Then this is sigma square. Sigma is square root 0.774147, that is 0.861. Example 9 in the book. This is the frequency and this is the midpoint. So sigma square equal summation fx over summation f minus summation fx over summation f, and this is x square and this is square. So we need three things: summation f, summation fx, and summation fx square. So summation f we will get 4 plus 15 plus 5 plus 2 plus 0 plus 1, and that is going to be 27. Then summation fx, f times x, 4 times 25, 15 times 7.5, 5 times 12.5, and 2 times 17.5, plus 0 times 40, plus 1 times 65. So this value is going to be 285. Then summation fx square, 4 times 25 square. Now by looking at, you can write 15 times 75 square, 7.5 square, 5 times 12.5 square, and 2 times 17.5 square, 0 times 40 square, plus 1 times 65 square. You will get this value as 0.5. Now you can substitute this formula. Sigma fx square means 6487.5 divided by 27. This is mean. What is the meaning of this one? X bar basically. Summation fx 285 over 27 square. So sigma square you will get 128.858, and sigma you will get the square root of this value. 128.858 equal 11.35. So this is the standard deviation. This is a small guide to work with the calculator. So Casio FX99EX. So go to menu, press 6, menu, enter 6, enter, go to menu, and then that is the statistical mode 6, and 1 the variable, and then there is no frequency column. We need to have this frequency column. Press shift, then fresh menu, then uh, press down with the arrows, then press 3 statistics mode, and then press frequency 1 on. Now we can enter the value, and now after enter the values we want to get the results, so go to enter option, then go to 3, and then scroll up and down. You can get all the details: summation f equal n, summation fx equal likewise, and the q1 mid f2, and finally I think shift 9 for clear the data. Make sure that you always clear the data before take the calculator, because the previous data may affect. This is shift 9.